The Beijing Academy of Artificial Intelligence just dropped Emu 3.5, and it is a genuine game changer. This isn't just another image model. In head-to-head benchmarks, this thing is already outperforming major players like Google's Nano Banana, Image, and even GPT-Image 1. It's what the researchers are calling a native multimodal world model. In simple terms, instead of having separate AIs for understanding text, generating images, creating videos, and editing them, Emu 3.5 is a single, unified model that does it all. And the craziest part? The version that's been released is a relatively small 8 billion parameter model, meaning it's designed to run on the kind of hardware many of us have at home. So let's dive into the examples because some of this stuff is just mind-blowing. First, let's look at how it handles long-form step-by-step instructions. Here's a prompt asking how to sculpt a Mars Explorer figure. In step 1, it generates an image showing all the necessary materials: clay, tools, brushes, and paint. Then, for each subsequent step, it generates not only a new image showing the progress, but also the accompanying text instruction. For step 2, it says, start by shaping the basic form of the Mars Explorer, and shows exactly that. Step 3 covers drawing the figure. Step 4 says begin painting and generates an image of the figure with a paintbrush on it. This continues for every single step, painting the suit, the helmet, and finally in step 7, applying a sealant. It creates a complete, coherent visual and textual tutorial from a single prompt. It does the same for a recipe on how to cook shrimp, celery, and pork dumplings. It shows the raw ingredients, the mixing process, wrapping the dumplings, and then the boiling process. It even includes the specific detail from the recipe. Once the dumplings float to the surface, add a cup of cold water to the pot. Finally, it shows the cooked dumplings being served on a dish, ready to eat. This demonstrates an incredible understanding of a process, not just a single static moment. The model is also a master of iterative editing and storytelling. Check this out. The task is to modify a sculpture's hairstyle and accessories. It starts with a base image of a character with short hair. Then, step by step, the model follows instructions to give her long straight hair, then change the color to blonde, add glasses, and finally a hat. The key here is consistency. The face, lighting, and background remain perfectly stable while only the requested element changes. It takes this even further with storytelling. Given a prompt about a clay astronaut crash landing near a glowing mushroom forest and being rescued by Pikachu, it generates an entire cinematic storybook. Page 1 shows the crash landing, the next he meets Pikachu, the subsequent pages show their journey together, sitting under bioluminescent flowers and entering a narrow passage, with one page for the image and another for the corresponding text, creating a beautiful, cohesive narrative from start to finish. Its single image editing capabilities are just as versatile. A prompt to change the material of the burning log to glass results in a glass log with fire still burning inside, a fantastic interpretation. A simple request to make the dog hug the cat does exactly that, keeping the same animals in the same style. It handles spatial commands effortlessly. A simple pan right on a painting works flawlessly. A prompt to convert to a view as if you are a bird flying above the building doesn't just crop the image, it genuinely infers and generates what the scene would look like from that new perspective. In another wild example, it takes a woman from a painting and a prompt that says she reads a book in a calm indoor location. It places her inside the scene sitting on one of the chairs. The style changes slightly, but the background is perfectly preserved. It handles complex edits with incredible precision. It can take the BAAI logo and transform it into a brushed metal version with industrial lighting, and the result is stunning. It understands multi-image prompts too. Given photos of a man, an eagle, and a restaurant, it perfectly composes a scene of the man sitting in that restaurant with the eagle perched on his table. You can spot a tiny inconsistency where a tablecloth is missing, but the facial consistency is excellent. It even understands numbered objects. In a busy scene where a painting on the wall is labeled Object 4, the prompt Change Object 4 to a movie poster flawlessly replaces it with an Avengers poster. Look at this colorful Halloween image that's transformed into a dark, spooky Halloween night scene with glowing macarons and bubbling green cauldrons exactly as requested. Even subtle human expressions are no problem. A photo of a girl is given the prompt, playful wink, tongue peeking out a bit. And the result is a fun, believable image that captures that exact feeling. For more practical uses, it can remove all handwritten annotations, both red and black, from a document, leaving the original text perfectly clean. Or look at this virtual try-on. Given a photo of a woman and a separate photo of a shirt, it renders the result, placing the new shirt on the same woman with perfect facial consistency. And now for what might be its killer feature, image creation, especially with text. It is phenomenal. It can generate beautiful photorealistic images that are hard to distinguish from real photos, like this one of a girl with white headphones from a Chinese prompt. But the text rendering is on another level. A detailed prompt for a whiteboard in a tech company results in a perfectly rendered board with the title Q3 AI Project Milestone and multiple sections with clean, legible bullet points. It even adds a sticky note that says Reminder, Team Sync every Friday. It can generate fun 3D scenes like a girl and a fox cooking together. Another example shows a person writing Emu3.5 technical roadmap on a board, and while he's holding the pen a little weirdly, the text itself is perfect. It can even generate an image of Albert Einstein writing complex equations on a blackboard, and though the chalk effect could be better, the text is accurate. It creates fun comic book-style scenes with squirrels discussing an acorn map, or two dogs plotting to blame a giant hole on the neighbor's cat, with the dialogue perfectly rendered in speech bubbles. It can generate a full cooking tutorial with 5 distinct steps on a single image, or a beautiful poster for bruschetta on a chalkboard background. This model is, in my opinion, the new king of open-source text generation. It doesn't stop there. The next section is called See, Understand, and Act, and it's all about embodied AI. The model generates complete, step-by-step, point-of-view guides for robots on how to perform tasks. We can see it creating instructions for folding different articles of clothing, and even a guide for clearing waste from a countertop. This is a massive leap forward for robot learning. But the most jaw-dropping feature is world generation. You can give it a single image, a living room, the Eiffel Tower, a racing car, and it generates an explorable 3D space from it. You get navigation buttons, and you can literally move around the environment it creates, looking left, right, or moving forward. It's not just an image generator, it's building a small interactive world based on a single picture. So, how on earth does it do all of this in a single model? The core idea is surprisingly elegant. It's built on a principle called next state prediction. The model is trained on over 10 trillion tokens, mostly from internet videos. Instead of just learning to describe a static image, it learned to predict what the very next frame of a video or the next word of a transcript would be. It's constantly asking, what happens next? By learning the flow of time and action from videos, it builds a fundamental understanding of how the world works. Under the hood, it's a standard decoder-only transformer architecture, which is then enhanced with large-scale reinforcement learning to get even better at following our specific instructions. But to make it fast, it uses a clever technique called discrete diffusion adaptation, or DIDA. Instead of generating an image slowly, token by token, DIDA lets it create a noisy version of the whole image at once and then cleans it up in parallel. The paper claims this makes image generation up to 20 times faster without losing quality. All right, the big question, can you get your hands on it? The good news is yes, you can. The code has been fully open sourced on GitHub, and of course, all the links you need are down in the description. As I mentioned, the benchmarks are incredible, with this 8 billion parameter model beating much larger and even closed source competitors. For hardware, the team has provided some great estimates. For full precision, you'll want around 16 to 20 gigs of VRAM. The 8-bit quantized version drops that to just 10 gigs, and the 4-bit quantized model should run in as little as 6 to 8 gigs of VRAM, making it incredibly accessible. There are 3 sets of weights to look for: the main Emu3.5 model, an image-specific version, and the vision tokenizer. Now, at the time of recording, the model weights themselves haven't been uploaded to their Hugging Face page just yet. The page is up, but it's currently empty. Keep a close eye on it, though, as they should be dropping any day now. As soon as they do, we'll get to do some practical tests and see just how good this thing really is. I, for one, am very excited, and you should be too. This feels like a significant moment for open-source AI. We're not just looking at a better image generator, we're seeing the foundations of a true multimodal world model that can reason about processes, tell stories, and even help build interactive environments, all while being accessible enough to run on consumer hardware. The potential here is just massive, from creative storytelling and education to robotics and beyond. Let me know in the comments what you think. Drop a like and make sure you're subscribed. Thanks for watching, and I'll see you in the next one.